Hi everyone, so today is day 19 of September LeetCoding Challenge 2021, and on this day we have to solve this problem, distinct subsequences. So I have already made a video on this problem under dynamic programming playlist. So in couple of seconds you will be able to see that video. So see you guys on day 20. Hi everyone, so today we'll be solving this hard LeetCode problem, and it is called distinct subsequences. And in this problem, like, we have been given two strings s and t, and we need to return the number of distinct subsequences of s which equals t. So basically a subsequence is basically like if there is a string and we delete some characters from it, so the resultant in resultant string that remains can be called a subsequence. Or like we can take some characters out of string, and if their relative positions remain same as in the string, original string, then that is called subsequence. So that is a standard definition. And let us understand the problem from the example. So we need to tell of this string as how many such subsequences are possible in this string s. So it is basically asking how many ways we can form rabbit in this string. So so answer is 3, because like we can form rabbit by first choosing the 4 letters and then taking I and T, this I and T. Then there is one choice that we will skip this 2b and take this 2b, and yeah, there is one way to skip the middle b and take the first and third b. So these are the 3 ways using which we can form rabbit, this string in this string. So that's why the output is 3. So you can take a look to the example 2. So in this, like, we need to tell how many ways we can form this bag in this string. So like we can form a bag by first taking b, then this a, and this g. And we can also form a bag by taking a, b, a, and then this g. And we can also form a bag by first taking b, this b, and then a, and then g. So these, like, there are in total 5 ways to form this bag. And yeah, so like in this problem, that it has been mentioned that the answer fits on a 32-bit signed integer, so we can return the answer in integer format. So we can take a look to the constraints now. So it has been mentioned that the length of the string and length of the string t, so the length of the string s and length of the string t, both of these strings have at most 1000 characters. So order and squared solution will be able to pass the test cases if both of them have part length n. And yeah, so we can try to understand how to solve this problem. So for solving this problem, like I'll be using a term. So consider that dp I comma j. So this term dp I comma j stands for the number of subsequence formed of this, like this I comma j stands that suppose j characters of this string t are taken. So just in case this j is 3, so this rab will be taken. So it stands that how many rab can be formed if the first I characters of the string s are taken. So just in case the I would have been 5, then we are like telling how much RAB can be formed in this RABBB. So that is the meaning of the dpi comma j. And for utilizing the dynamic programming in this problem, like we need to consider the state transition. So how can we relate this dpi comma j state in terms of this smaller subproblem, so similar subproblems? So yeah, so they like we can understand that if we are checking for how many subsequences are possible in the first I characters of the s, then like this number will also include the number of subsequences that are possible in first I minus 1 characters of the string s. So this is first of all like equal to dpi minus 1 comma j. And yeah, there is one more thing, that what if we are utilizing this ith character of the string s? So we can only utilize that if the last character of the string t, that the portion of the string t that we are considering is equal to the portion of string s. So in that case, we can take b of these two strings, and we need to find the number of subsequences possible of this smaller part in the first I minus 1 characters. So just in case the last character of these two parts of a string are same, then we can also add dpi minus 1 j minus 1. So we will only add this thing if like this condition will be true. So this is the main idea of solving this problem. So we can try to implement this problem. So first of all, we'll be storing the size of the string s and a string t. So I will call them n and m respectively. Now what I need to do, we will be returning the answer. So I'll be using a function, recursive function dp, and this dp stands for how many, like if we are taking the first j characters of string t, so how many ways we can get that small portion of string t among the first I characters of string s. So first parameter will be I, another parameter will be j, third parameter will be n, and then we will have m, and we will also need string s and string t. So this is the signature of this function, and we will also need to store all the pre-computed subproblems so that we are not computing it again. So I will be using an unordered map for that, and I will be hashing int to int. So the reason, so how can we hash? So basically, first of all, we'll be forming a key from this I and j, and that is what this int will be like we will be using an integer key made of I comma j, and that will be, we need to ensure that we are making a key that will be unique for all these I and j, for all the different pair of I and j. So since the limit on I and j is 1000, we can multiply I into 2000 and then add j to generate a unique key. So I'll be hashing the results using this key. So first of all, we can handle the corner cases. So if j is I is 0, right? No, first we need to check whether the j is 0. So just in case, we are checking the number of ways of formation of an empty string, then that is 1. Like that is obviously not choosing any string. And then comes the case when this j is not empty. So if I will be less than j, so the another case is that when this I is less than j, so like obviously it is a trivial thing that if the number of characters in a string s is less than the number of characters present in the string t, then we cannot form any subsequence. Like we cannot find any subsequence of this string s which will be equal to string t. So in that case, we can return 0. So we can then form the key. Yeah, and we need to also complete this thing. So we'll be starting from So the answer will be n comma m, because we need to like find the number of ways this string t can be found in the first n characters of the string s, and then we can pass the n and m and s and t. So this will be the answer. And if the problem is not pre-computed, so how we will be checking that? We can do something like that: lookup.find and key. So if that problem is not pre-computed, then it will be equal to lookup.end. So we'll be computing the answer of the sub problem, and then we'll be storing it into lookup of key, and in the end we can return lookup of key. So first of all, we will include the case. First of all, we will add all the or the number of ways of finding the part of string t in first I minus 1 characters of string s. So that will be I minus 1 j n m s and t, and just in case the last characters of both these part of the strings are same, so we'll need to check that. So this will be, we can also add the number of ways to for the j minus 1, like first j minus 1 part of string t in the first I minus 1 characters of string s. So yeah, and this is the number of ways for this particular sub problem. So we need to store that, and this should solve the problem. So we can do the complexity analysis. So like there are n possibilities for I and n possibilities for j. So there are total n squared ways, and for computing each sub problem we are only doing order 1 work. So the time complexity is order n squared. Similarly, space complexity is also n squared for like storing the for storing this sub problems. So we need to like make n squared unique keys for storing the solutions. So we can try to run it on the sample test cases to check for the compilation error, and yeah, it is working, so we can submit it. Yeah, so it got submitted. So thank you guys. See you again in another LeetCode hard problem.